Welcome to the Austin Python Meetup. Thank you all for joining us. We have two speakers tonight. We have James Powell, who was in Austin, but now he's in New York. But he will join us because of his Austin days. He remembers Austin nicely. And he will tell us about Python 3.9. By the way, check out James Powell's talks on other topics on YouTube. You'll find many of them. Those are very useful to look at. The second speaker will be Katrina Riehl. She will talk about NumFOCUS and some security issue related recently. Katrina has multiple hats. She's the head of data science in Cloudflare, but she's also, I believe, the treasurer in NumFOCUS. And NumFOCUS also, James also is a member of NumFOCUS. I can't remember exact role, so they will tell it while they speak. And NumFOCUS is something that Katrina is going to talk about, but this is an organization that every person who's involved in Python should know about. So without much ado, James, show your capture the screen and start the presentation.
Okay, hi everybody. So I'm James Powell. Just before we get started, I'm going to share a link with you in the Meet chat. It's a link to Teammate. So when I share my screen, if you can't see my screen too clearly, if the video is not that great, just feel free to click on that link and you'll be able to see a much clearer view of my screen, just in case it gets a little fuzzy. So as Jacob said, I'm James. I have a bunch of talks on YouTube, along with Katrina and also Jane, who won't be speaking tonight. We serve as 3 of the board members for the NumFOCUS board. I serve as co-chair, Katrina actually serves as treasurer, and Jane serves as secretary. So hopefully in Katrina's talk, if there's any material about NumFOCUS that you're interested to ask more about, you'll have 3 people who can give you an authoritative view. Tonight, I'm going to speak to you about something maybe a little bit less interesting and a little bit less community related, a little bit more technical. We'll talk about what's new in Python 3.9. And the good news is, if you happen to fall asleep during this presentation, there really isn't a whole lot that's new in Python 3.9. And so I'll cover just a couple of interesting things that I've noticed that have come out in Python 3.9. I put this presentation together about a month ago, so a couple of new things have slipped in that I hopefully I've covered all of them. And so if you give me 1 second, you should see my screen behind me. I'm going to hide in just the lower corner, or actually, you know what? I'm going to move myself a little bit. I'm going to make myself even smaller, just because I want you to see part of the conceit that we have tonight. And so part of that conceit will be, let's make sure you can see my screen, will be, and so here you can see the conceit a little bit, Python 2.7 in the top, 3.8 in the middle, and 3.9 at the bottom. And so let's just get started with what's new in Python 3.9. As I said, there's not a whole lot. I think one of the most major differences in Python 3.9 is that there's no longer any community-supported releases of Python 2. The last community-supported release of Python 2 came out about 6 weeks ago. And so if you still have code bases in Python 2, now is probably a really good time to start moving them over. You can see that even Python 3.9 has also begun the process of deprecating a couple of things. One example is for example, the collections.abc module, you can get access to this thing mapping that you might use in order to create, you can use mutable mapping to create a subclass of a dictionary and to automatically get certain behaviors from that. It moved from the collections module, the collections.abc module. You can see there's a deprecation warning in my Python 3.8 and 3.9 interpreters. There will be some things that are changing from Python 3.9 to 3.10, specific deprecations. And so if you actually grep through the Python 3.9 codebase, you can see there's quite a few deprecations where things will start getting removed, not in this release, but in Python 3.9. Most of these are in async IO, and the only one that's really interesting is don't import mutable mapping or mutable or any of the ABC types from the collections module anymore, because that will go away soon. But for Python 3.9, not a big change. Now, in terms of other changes in Python 3.9, I think one of the most major ones, and by the way, if you want to conceptualize 3.9, I would say think about it kind of like 3.7, a couple of interesting syntax changes, a couple of standard library changes, but nothing that's really fundamental. This isn't a 3.6-like release that really changes the way that you write your Python code. One of the fundamental syntax changes, or one of the built-in changes, is dictionary merging. And so for those of you who've ever had to take two dictionaries and merge them together, back in the day, we used to have to make a copy of one of those, update the other one, and it used to take us 2 lines of code to merge 2 dictionaries together. And then, you could find some ways to do this in just 1 line of code. You could use chain from the itertools module to chain the items together and to build a dictionary from that. It's a little bit ugly, a little bit clumsy. You could find some other ways to do this. You could use comprehension syntax and this little trick with comprehension syntax where you have a double for loop. And yeah, that works too, and it merges the 2 dictionaries together. If you didn't want to have a copy of the dictionaries, you wanted to have a live merging of them, you could use chain map from the collections module. It's another way that we could take these 2 dictionaries and combine them. But if we think about all the built-in or all the standard library types we have, there's nicer syntax for things like the collections.counter. You can add collections.counter objects together. You can union them together. These operations mean very slightly different things, but you can see it's very nice, very lightweight syntax. If you think about the built-in types, like our set type, you can union sets together. And again, you have some very nice syntax here that is something that people might want to bring to our built-in dictionary type. Now, one interesting thing that comes up, and part of the discussion around the introduction of dictionary merging using very nice lightweight syntax, was whether this was going to be a commutative operation or not. And even with set unioning, it's not commutative. And so one interesting side effect of the 0 value and the Boolean values, or rather the 0 and 1 values and the Boolean values being equal to each other, is they hash to the same thing. They're equal to the same thing. And so unioning 2 sets is not necessarily a commutative operation. If you swap the operands, you might get a different result. And you can see that here in Python 3.8 and 3.9. A somewhat unrelated, but maybe kind of in the same vein, little thing you might have seen in Python is you may have seen that the nan object is probably one of the very few built-in objects that you have that's not reflexively equal. That is, if I create a nan object, it's identical to itself, but it's not equal to itself. This is very rare. You can think of this as though somebody wrote a custom object and they just said the EQ always gives false. It's a fairly rare condition. Now, in the case of the nan, it kind of makes sense because you can think of the nan as not really being a number. It's an error condition. So the error condition shouldn't necessarily be equal to another error condition. And it results in some very strange behaviors when you have collections and when you try and figure out, will a NumPy and D array behave just like a Python list from a collections perspective? Because when you do things like the equality of collections in Python, it does an is check up until it finds a different object, and then it does an equal check. And so even though a nan is not equal to itself, a list containing a single nan is equal to a list containing a single nan. So you get this weird discontinuity. And in the case of a NumPy and D array, the NumPy and D array's equality concept is based off of a strict equaling of all the operations. And so you'll see one of the fairly rare differences between just simple operational arithmetic type behaviors on a NumPy and D array versus a Python list, where it's the case that if you compare 2 lists for equality or 2 NumPy and D arrays for equality, you won't get the same result. Now, in my Python 3.9, I don't have NumPy installed, which is why you see that error. My Python 3.8, that's what you should be focusing on for this purposes. One other interesting thing is even if you do the .any, obviously it's going to tell you the exact same thing as the equal. And the only reason we might do the any or all is that we know that the truth value of a non-empty NumPy and D array is ambiguous. Use any or all. And it's kind of sad that somebody's gone to the point of seeing that error enough to memorize it. Now, if you remember, like PEP 3132 with extended iterable unpacking, back in the Python 2 days, if you had an iterable, you could only unpack it into variables if you had exactly the same number of elements on the left-hand side and the right-hand side. But in Python 3, we extended this very slightly. In Python 2, it was the case that clearly if you have 4 elements on the left-hand side or 4 elements on the right-hand side, you can't, or not the same number of elements on the left-hand side or the right-hand side, you can't perform an unpacking, you get a value error. Either need more than 3 values, not enough values to unpack. The PEP 3132 extended iterable unpacking gave you the ability to throw extra arguments away. And so something like this works in Python 3, 3.8, 3.9. This was actually introduced very early on in Python 3. And it's surprising that a lot of people haven't seen this syntax. And so, all of these examples work. You can unpack something and just kind of throw the rest of the options somewhere else. Now, this also led to additional unpacking generalizations, PEP 448, which gave us the ability to unpack into structures. So you can unpack a range into a tuple. You can unpack a range into a list. You can unpack it into a set. You can unpack all sorts of things, which led to an interesting little shorthand that some people like. When you're when you're trying to define an empty set, you have to write set out like this because the dictionary came first, and so the empty curly braces represents an empty dictionary. But you can use this unpacking syntax in order to write an empty set without having to use and without having to perform like a lookup on the set function using a literal syntax, although you don't save yourself any keystrokes. This also leads to something that has been missing for some people, which is, we have a list here, we have a list comprehension here, we have a set comprehension here because now we have curly braces, we have a dictionary comprehension because we have curly braces and a colon, and here we might expect we have a tuple comprehension, but when we actually run this code, we see we get a generator expression. Well, this also leads to something that people have been missing for a while, which is the tuple comprehension. Now, taking this back to the idea of merging dictionaries, the generalized unpacking also gave the ability to merge dictionaries. And so for the most part, when people wanted to merge dictionaries and make a copy, not use a chain map, but make a copy, we'd use a simple syntax like this. Now, when you look at that, you might say, okay, that's pretty short. That's pretty easy to read. It's easy to see that D1 is first put in and D2 takes priority over D1. You can kind of reason about it, but it was considered to not be sufficiently obvious to newbies. And so Python 3.9 adds, and I'll skip over this section in the sake of time, adds a unioning operator on dictionaries. And so it's not really going to change your life, but now you have a simple, fairly consistent syntax, consistent with the dictionary subclasses in the collections module, consistent with the set type, where you can merge two dictionaries together. It's lightweight, and it's considered to be a little bit more discoverable. Now, beyond that, we get into some other changes. Changes in built-in objects is fairly rare because you can think of the backwards compatibility and the forwards compatibility requirements that they incur. And so the string module got some new methods in Python 3.9. PEP 616 added two new methods to the string object, starts with and ends with, remove prefix and remove suffix. And so here you can see I have two strings. If we have a prefix or a suffix in them, we can index them using slice notation. And so I can remove that. Well, in Python 3.9, I can do this with a remove suffix or remove prefix call. Now, the remove suffix and remove prefix call are approximately equal to this syntax. One thing that you might wonder is if the prefix doesn't exist, why do I do a slicing notation here? This is something that came up when I was looking through the PEP and trying to understand the PEP. And it's very interesting. A slice of a string, of a built-in string, a Unicode object, is equal to the underlying object. It's just the exact same object because it's immutable and you can return the same object. And there shouldn't be any distinction here. And so you might wonder why it is that somebody might ever do this. Well, I actually had to go digging through the source code to figure this out. And so if you actually look in the Python Unicode object code, and you see what happens when you perform a slice. If you perform a slice and you get the exact object here, if the start is 0, the step is 1, and the stopping point is the whole thing, you get the unchanged object. But this will actually do something very slightly different if you happen to have a subtype of a string object. And so that notation you might see, and you might actually say, oh, actually, this is maybe the case if you have a subtype. I thought that was an interesting aside. Beyond that, you can think, if I have a prefix or a suffix on my string objects, I can now remove them. This might be useful for, if you have like a pandas and D array and you want to use the additional str operations, a pandas data frame, you want to use the str operations on it. Removing and adding prefixes may be a very common operation, which you can now access a little bit more conveniently than having to do like a dot apply with a complex function. Now, you might think that this might be useful for like file manipulation. You could remove the suffix corresponding to the file extension in order to give a new file extension. But if we back up a little bit and think about what strings mean, we can see why maybe there's better ways to do this. For example, if we wanted to model something like an IP address, we could think of a couple of different ways to model an IP address. We could model it as 4 integer values, but we could say this is kind of phony because I don't usually need to get the individual octets independently of each other, and I don't usually need them to be integer objects because I don't need to do arithmetic operations on them. Also, I'm not asserting my range here, so this could inadvertently include non-byte values. And so you might think there's other ways I could do this. I could model this as a single int, and that itself is still kind of phony. I could model this as a string. That's not so bad. You're kind of representing this as being an opaque type. You could model this as a byte string. I recently had a case where I was working with some client code and they had ACID IDs, and I made the argument that ACID IDs should actually be byte strings because they're not numeric values. You can't add them or subtract them. They're just opaque bags of bits. And you can think with a byte string, it's a little bit more compressed than if you have to model this as just a Unicode string. But you might think if I really want to do something interesting with them, I might use the IP address module in the standard library. And then I can do interesting things like ask, is this IP address a loopback address? I can ask, does this IP address belong to this net mask? It turns out that in Python 3.9, some small changes were added to the IP address module. So if you're interested in modeling network level things like IP addresses, RFC 4007 has the idea of zone indexes and scoped addresses, and this was actually added in. So this is one of the interesting cases where you'll see the code here does not work in Python 3.8 because the IPv6 address in Python 3.9 now has the ability to represent IP addresses with the zone index. This is often used for example, specifying the interface that the IPv6 address corresponds to. Now, going back to the file system example, you might think that we have an equivalent idea of something a little bit richer than a string for representing file system. And so probably the better thing to do than to represent, to modify a file system path as a string object using remove suffix and add suffix would be to use pathlib and to use operations such as with suffix instead. And so I would say that if you want to conceptualize this string operation, just think there's another operation here. It might be useful. It might be useful if you want to do your additional accessors to your pandas data frame. But beyond that, some of the use cases that might pop into your head aren't necessarily going to be use cases that are not better served by other tools. Now, there were some changes to the PEP 484 style type hinting. PEP 585 was accepted type hinting generics and standard collections. I don't have a very long example for this, in part because I have yet to actually find a really good use case for PEP 44 type hinting in any of the code bases that I've written. And so I'll skip over that. I'll let you, if you're interested, take a look at PEP 585. There were some minor changes made to existing parts of the standard library. String replace, if you give it 0 to do 0 places, has a very slightly different behavior. You can see it in the 3.8 and 3.9 examples here. If you tell it to do 0 replacements, if you tell it to do exactly 1 replacement on an empty string, rather, it'll give you the empty string. It'll give you 1 replacement versus the empty string back in Python 3.8 versus 3.9. Very, very, very minor difference. Now, a much more major difference, but one that you won't really see, is that Python 3.9 now includes a new parser. I think Guido's latest pet project was looking into different manners by which you can parse grammars. As you might know, that the Python parser was originally handwritten, and then it moved into being something that was generated by a grammar file. So if you ever look in your Python source code, you can see there's grammar, and grammar has an extended BNF format, and then it automatically generates C code and Python code as part of the build process. This has been moved over to a new peg parser. There's still a couple of small little bugs have been seen in it, but for the most part, you won't see any different whatsoever. In fact, the most major syntactical difference in Python 3.9 versus 3.8 is not a consequence of the new parser. I think that the only time you're going to see a change course or resulting from the new parser is going to be if, for example, this allows the core developers to iterate more quickly on more fundamental changes to the grammar. But so far, I don't think you'll see anything. Now, there is one very interesting change to the Python grammar. Historically, when you were working with decorators, you were limited to a dotted name syntax for what a decorator could be. So just as a very quick refresher, Python PEP 614 relaxing grammar restrictions on decorators, it lifted a restriction that existed for a very long time. So let's say we have some decorator here, and all it does is it times some function, and then we apply it to some function here. We know that that's the equivalent of the syntax just saying, bind this name f to the result of this function being called on f. We know that this thing here doesn't actually have to be a function. It doesn't have to return a function. So often when people say a decorator is a function that takes a function and returns a function, this is somewhat imprecise. A decorator is strictly just a syntax for representing a rebinding of a name when you pass what is originally constructed via that name using def or class syntax to some kind of callable, where that callable could be anything. And so a canonical example of where you can start to kind of push the boundaries of what a decorator is if you have a class as a decorator. So here, this is a pretty interesting canonical example here. Instead of having the decorator be a function that returns a function, it's actually a class that returns an instance. And so this gives you a very compact way to represent caching or memoization of a function, because you use the underlying dict type in order to represent the memo itself. And so this is my favorite example of why a decorator doesn't have to necessarily be what you think it is. And so if you run this code, you can see just a simple decorator that does some caching. Now, it turned out that the only syntax, and as an artificial restriction that you could have for a decorator, was something dot something dot something and then a call. And so other syntaxes were not allowed. Now, if you dig back into the Python mailing list and the history of Python, you can see that this was a fairly arbitrary choice made by Guido. It was just thought, look, nobody's asking for more syntax than this, so we'll just restrict it. You can actually, in prior versions of Python, remove this. It is literally a 3-line change. You go into the grammar and you swap out dotted list with expression list, and then you change 2 unit tests, and then you remove this restriction. The reason it's taken this long to actually be made, this change to be made in Python, was that it took a PEP and it took a lot of discussion to see, well, is it worth opening up this restriction? I'll give you an example or two of where that restriction is helpful. You may have seen this in a couple of libraries where people create like a dummy decorator that looks something like this in order to relieve themselves of this restriction. So they can do something like look up a decorator in a dictionary. And so here you can see this thing looks up 2 decorators from some dictionary. And you know, that's a little bit clumsy of a syntax. I've seen this once or twice in open source projects. And so in Python 3.9, you can just have any arbitrary expression here to look up the decorator. Another interesting thing that you might or might not be aware of is if you have like an assert in your code, so let's say assert false equals true, or let's just do assert false. This actually gets removed from your code if you're running with optimization. So if I run this with just normal Python, you can see, and let me run this function itself. If I run this with normal Python, you can see this assert will be triggered. If I run this with optimizations Python-O, the assert's actually elided from the source code. So if I disassemble this, you can see in Python without the optimization, you can still see the assertion. You can see the assertion error. With the optimization, it gets elided. One thing that a lot of people are aware of is if you have a statically determinable and constant foldable if condition, that also gets elided from your source code. So if I just put a print here, this if will actually get elided from my source code depending on whether I'm running with or without optimizations. Well, that leads to a very interesting thing you could do with decorators now, which is you could have a decorator that gets applied in optimization mode or non-optimization mode, and you can write it without any clumsy syntax. And so this is probably one of the use cases where I might start to use a decorator, you know, remove it if it happens to be if you happen to be in optimization mode. And so you might be able to add decorators for debugging purposes. Now, there have been quite a few standard library updates, and I'd say the majority of the work on Python 3.9, other than bug fixes and general code cleanup and the new parser, has been library updates. So I want to give you a couple of the library updates in the time I have remaining. Some of them are very minor, like simple namespace from the types module now gets p-printed nicely. And so you can see between the Python 3.8 and 3.9 example, one of them is printed all on one line, the other one's pre-printed a little bit nicely. I don't know that I've ever really used simple namespace. It was originally intended to be a very simple way to do something like class NS with a nice printer. I don't know. It doesn't seem to be something that has come up that much. The math module got a couple of extra methods in it. You can get the greatest common denominator and least common multiple. You can also do next after. This is something that Julia has had from the start that Python hasn't had, the ability to operate on a floating point number as a bit pattern and to get the next item by incrementing just that bit pattern. So you can think when you look at your floating point numbers, they're not arranged contiguously or they're not arranged consistently on a number line. You know, the location of that number with respect to how close it is to 0 will change its precision. If you want to get the next largest number, then you can use next after. What you can't unfortunately do in Python yet, and I don't think you can even do in NumPy, is make use of all the bits that aren't set in the NAND. The NAND type's a very interesting thing. If you actually look closely at an IEEE 754 double precision floating point NAND value, it only has a number of values set. I think the last 8 or 12 or 16 of the bits are actually reserved for an application payload. As far as I can tell, there's no way to access the application payload in NumPy or Pandas or pure Python. And so I've tried a couple of experiments with maybe you could use next after in order to generate these and then do something interesting with them. But unfortunately, I haven't come up to anything. Now, another very interesting thing, but still somewhat marginal in terms of its use case, is the AST module has now has the ability to unparse an AST. And so in Python 3.8 or even in Python 2, you can take some code, you can parse it, you can manipulate that AST. The AST module has a node visitor, so you can do programmatic manipulations of an AST. People use this for code transformation techniques if they want to operate on the AST and not operate on the bytecode. And in Python 3.9, you can now do a round tripping. And so if you think about tooling that you might build around Python, one of the interesting things is in Python 3.9, it's now a lot easier to build this kind of tooling if you do AST level manipulations, because you can manipulate the AST and then you can regenerate the original source code from that. And so here in this example, you can see, you know, I take some AST x equals 1, I change what the variable is, I change what the value is, and I can unparse it right back to the source code. So you can think that kind of round tripping you originally had to do, or prior to Python 3.9, you had to do manually. Now you can do it automatically. And you can ensure that you don't have to manage the transformation from the AST back to the source code. That's now managed as part of the standard library. So that makes it a little bit more robust because it's no longer your responsibility to keep up with any changes that are made to the grammar. A couple of other things have been changed. Zone info has been added to the standard library. I believe this eliminates the need for the PyTZ third-party module. And so now in pure Python with the standard library, you can actually add time zones to your datetime values. And so here you can see I create the July 4th with America, New York, and I can ask it for its info. A new module has been added to the standard library, GraphLib, for topological sorting. I believe this was added in order to help facilitate some of the things that are being added to PyPI for better dependency resolution. But this is now beginning to get to the point where I don't actually think this topological sorter is altogether that useful. It reminds me a lot of the statistics module in the standard library, which is it's not really purpose-built, and if you really were doing something with hardcore with statistics, you would probably use SciPy or stats models or a more purpose-built tool. You wouldn't really use median from the statistics module in the standard library. In the same sense, if you were doing anything heavyweight with graph objects, I would think you would want a much better representation of it than dictionaries of dictionaries. You'd at minimum use the dictionary of dictionary representation that Network X provides you with, and Network X provides you with a topological sorting. It's just in the core Network X library, and so I guess for some particular uses for some core developers, it might be useful to have this, but I'm not altogether convinced that this is of general interest. Something that is also a very minor thing is, as you might know, we have 3 regimes of dictionary ordering. Prior to Python 3.6, we considered dictionaries to be unordered types or machine ordered types. They were ordered by the ordinal value of the hash values that were put into it, subject to whatever the perturbation of the open addressing scheme was. In Python 3.6, an optimization was, a split table optimization was added, which then forced dictionaries, or as a consequence, had dictionaries assume insertion ordering, similar to the ordered dict subtype in the collections module. In Python 3.9, or rather in Python 3.7, that behavior went from being a side effect to being part of the standard. And so in Python 3.8 and 3.9, dictionaries are now ordered by human ordering, by insertion ordering, which means effectively either insertion ordering or lexical ordering, depending on whether you're talking about a literal or something that you've manipulated, by the standard. As a consequence, other parts of the standard library that required ordering, for example, the inspect module's representation of a bound signature, originally required that the keyword arguments have a particular ordering associated with them, and so you have to use an ordered dict. Now it uses a regular dictionary. And so you can see some of this behavior is now being spread throughout the standard library. One of the downsides of this moving from being a side effect to standardized behavior is that it's now going to be a lot harder for us to advocate for swapping out the Python dictionary with higher performance hash table types, many of which, like Google's hash table type, do not assume ordering of any type. And it also means that the collections.orderDict is much less useful, even though it wasn't really that useful in the first case. The only difference between a built-in dictionary and the collections.orderDict is the order considered as part of equality or not. For the order dict, the order is considered as part of equality. For the normal dict, it's not. There was some discussion on the Python mailing list as to whether normal dictionaries should consider ordering as part of equality, but that's going to break a lot of code, and also it just seems unnecessary, so that wasn't made. And then finally, the last change that I picked up that might be interesting is you can get random bytes from the random module now. Again, this is a case where if I were ever really generating random bytes, I'd probably just use NumPy, and I'd probably generate something a little bit more specific than random bytes. I'd generate random, U and 8s in some aggregate fashion. But here you can see you can generate those. There were some optimizations added to Python 3.9. You might or might not see them. One pattern that you might have seen is in a list comprehension. Sometimes you refer to the same thing twice. You can see in this list comprehension, we're referring to f of x twice. So we're computing f of x 2 times. This is somewhat unfortunate because if f of x is slow, then we're incurring that penalty twice. Now we can do a couple of manipulations here. Like we can use that same, double for loop in order to avoid the extra computation. So we could have this computed once in this inner for loop and then used twice. And so that's one way that people got around this in the case where they wanted to use a comprehension syntax, but they didn't want to pay the penalty of computing this thing twice. You can think this kind of works because if you unravel those for loops, you get some syntax looks like this. So this is really just, doing in a list comprehension an embedded for loop that has over a list with 1 or 2 items is effectively just a way that you can get variable binding. If you think about it in that sense, you can think with assignment expressions that were added to Python 3.7. This is possible to do in Python 3.7. And so here in Python 3.7 and later, you might use the assignment expression syntax in order to avoid the duplicate computation here. Optimizations were added around this specific syntax. And you can think that there's still maybe one reason why you might not want to choose this syntax over the previous syntax. And one of those is whether you leak in and out of scope. And so here you can see if I have a list comprehension in Python prior to Python 3.4 or 5, I want to say, in the Python 2 era, this comprehension variable would actually leak in the scope outside. So you can see in my Python 2.7 example, you can actually see that variable in the scope. you can no longer see it in scope. And so unfortunately for the assignment expression syntax, even if you put it in a restricted piece of syntax like a list comprehension, you can still see the assignment expression outside of that because Python doesn't have nested scopes. It only has a local closure and global scope. And so there is one unfortunate side effect of using this particular syntax, which is that you do leak scopes. And so that might be something that you want to avoid if you're using name errors as some part of your static verifiability mechanism. And so those are the changes that I saw in Python 3.9, reviewing the changelog, reviewing some of the discussion on the mailing list. That's all I have to present to you. There were a couple of other changes. Some of them are very, very, very minor that I really struggle to see how they might be relevant to a general audience. There may be some future changes. We just saw 2 releases of Python 3.9 come out yesterday, one botched release and then a fix for that. We're at Python 3.9, I think B3 with the release candidate coming out fairly shortly. And so for the most part, this should be your conceptualization of what's new in Python 3.9. I hope you enjoyed this talk, and that's all I have for you. Thank you so much.
Thank you, James. Very good talk. I did have some technical glitch at the beginning, so some of the beginning of the talk, nothing significant has been cut out of the recording, but hopefully it won't be a big deal when we put it on YouTube. I'll try to paste things back and put them back, but hopefully it will be good enough. I do have a question for you, but I opened the floor for questions from everyone, but I'll start with one. The optimization option that you showed in Python 3.9, how well did it evolve throughout the years? Like, is it really very good? Is it comparable to tools like PyPy, or is it like something that just does the very minimal? Whatever you think.
My view personally is somewhat controversial, and I would love to hear what Katrina has to say, because Katrina, goes back all the way to the numeric and NumArray days, and so she's seen every attempt that people have made for trying to optimize Python. My view of optimizations of Python is that Python is intentionally written to be a very simple interpreter to make it easy for people to contribute to it. I remember back in the early days when trying to understand how PyPy worked, I couldn't even figure out where the entry point was, whereas with CPython, the code base is really, really easy to find your way around. There are very, very minimal optimizations added to CPython. People Optimizer was added a couple years back. A colleague of mine, Joe Jevnik, suggested some additional optimizations for the People Optimizer, which were then rejected. And so optimizations of pure Python code really aren't anything that the core developers are focusing on, other than, for example, optimization of things like dictionary types, where they don't have some user-affected result. My view of Python from that perspective is PyPy is probably a non-starter for most people if they need to use NumPy or Pandas or one of those libraries. And so my view of optimization in Python is Python as a program structuring tool is very powerful. If you focus your optimization efforts at the root level, picking good algorithms, good data types, and figuring out how to expose certain details of your program structuring, you can then add in your optimizations at the leaf level to make use of that. One example is I gave a presentation the other day involving Thomas Caswell, and he talked about some of the framework that they've built for NSL2 at Brookhaven National Laboratory, where they use a generator framework. And because generators represent a lazy computation and they can see each other, you can do things like tag generators and then do automatic elision of generators in a computational pipeline. And so you could have like f of g of h, because they're generators and they're lazy, you could have f see that it's a composition of g and h, and then elide themselves and then swap out with C implemented fused operations. Or I showed an example where in 25 lines of code, you can do predicate pushdown. You could write your own framework using generators that can see that they're generators, and you can see a map can see a filter and then perform some swapping to do predicate pushdown. And so that kind of optimization is, I think, much more interesting. Everything else either seems to go the way of like the NumPy, Pandas, PyTorch approach, which is these restricted computation domains. People like to talk a lot about things like slots, and I think it's the biggest distraction, because what you see is when you're dealing with large pieces of data in your program, you end up needing to draw a red line around those, create like a manager class, your NumPy ND array, your Pandas data frame, and then start swapping out, have the manager class intermediate any access to the underlying data, perform boxing and unboxing as you move in and out of that domain, and then when you're inside the domain, start swapping out parts with highly optimized, Fortran, C, assembly, whatever. I think Numba tries to blur that distinction a bit, but I don't really have a good measure for how successful Numba has been in practice for real code bases.
Thank you. I know Number is been used extensively recently. Maybe Katrina can talk about it a bit more, but I have a bunch of questions that people just put on the chat. By the way, you are welcome to unmute yourself and ask James directly, but I'll go through the chat. Could you talk more about introducing topological sorting for graphs? This is from Akef.
Okay, let's see. Let me take a look. So the topological sorting, my guess, I didn't go too deep into the history for why this was added, but my guess was they wanted topological sorting for certain things like, let's say you have package dependencies, you want to resolve that in some fashion. You can do the topological sorting in order to figure out. Topological sorting is effectively your level order traversal of a tree, and so you can say, oh, given this dependency graph or this dependency tree, these things are at the same level, which means these operations could be done simultaneously. For example, these packages can be installed simultaneously. I think it's not altogether that useful to add that to the standard library, because what you really need when you're dealing with graph or tree data is a better data model than dictionaries of dictionaries. You need like a NumPy equivalent for it, and it's unfortunate that nobody's really developed something like that for Python yet. And the reason for that is, you eventually run out of memory, right? A big graph and everything's a Python object, and nothing is contiguous in memory, and nothing's cache coherent, and everything is, a fat Python object. You'll run out of memory. And so, I don't know. I think the topological sorting it's like the statistics module. Like if you're doing anything serious, you probably blow right past it, right to the purpose-built tools. And NetworkX is not ideal by any means. It is an extremely limited tool, but it's really easy to install. A lot of documentation, and it adds everything. Like you're gonna model a graph as a dictionary of dictionaries and use graphlib with topological sorting. And then what if you have to, I don't know, do like a star or Dijkstra's? You have to write that yourself? No, you're just gonna go straight to NetworkX and call it a day.
Well, maybe the reason is actually what you said before. Maybe the core developers needed something like that, and therefore, and since they use only their own libraries, then maybe they just wrote
Very possible. Very possible.
That's an assumption. Looks right. Jenny is asking. Thanks for the talk. By the way, multiple people thank you for it. Where do you see benefits up cases for remove suffix prefix? What was the argument to add to the string? Thanks. I kind of had problems figuring it out. It's on the chat.
I think that it might be tempting to think that you might use this for things like file path manipulation, file system path manipulation. I mean, whatever you need to remove a suffix or a prefix. And so where I would see that I would end up using it myself is oftentimes when I get large data sets and they're in a pandas data frame, and they revolve around not numerical information, but business information like asset tags or asset IDs or physical devices. I need to perform manipulations on that, and I have to go into the string module. And so often, you query some database and it represents, I don't know, BMCs in a data center, and they all have like an asset tag on them, so the people who purchase them and install them can uniquely identify them and figure out when to RMA them. And you look at those things and they encode information in them. You need to then perform string manipulation to pull that information back out. Well, that's what your string operations are. And so being able to access those through the pandas accessor can be very helpful. I'm sure I have more than once had to remove a suffix or a prefix where there was some suffix or prefix on that. But other than strictly what it says on the tin, I don't know that there's anything really special to those two operations. Other than we added new operations to the string type, which is a relatively rare thing to see happen. You don't see new methods added to built-in types that often.
Akef is asking, are there any plans for having a practical solution for compatibility issues with Python 2? That's a loaded question.
Don't use Python 2 anymore, right? Stop using Python 2 is the answer. So what people had supposed is that when the community would stop supporting Python 2, third parties might step up. Third parties like Red Hat, IBM, or even Anaconda, or who knows, Nthought, or Active State might step up and support Python 2 as a corporate entity. I don't think I've seen anybody willing to step up and do that. And so the answer is, the community doesn't want to support Python 2 and nobody else wants to. Yeah, you can go and you can find the Python 2.8 project on GitHub. I don't know how popular that is in practice. I would suspect that your major thing would be is you start writing your code against Python 2.8, and then you want to use NumPy or Matplotlib or Pandas, and you want to use Pandas, some new feature that comes out in Pandas, like masked integer arrays or categorical. And then you're like, oh, Pandas drop support for Python 2. And if there's a bug when you're running your Pandas code against Python 2.8, the Pandas developers aren't going to fix that, right? They have no incentive to fix these kind of niche projects. And so you just bring on a lot of burden for maintaining that for yourself. Or if somebody brings up, we talked before the thing started about VAX. Does it support Python 2.8? I maybe not, but I don't think you're going to get a lot of support from the community to fix any bugs that you see in that. And so the answer is, once the community drops it, the rest of the world probably will drop it. I suspect there's no money to be made in supporting Python 2 anymore. And so everybody's either moving away from Python or they're moving their Python 2 code to Python 3 code.
There are some things that are still in Python 2. The question is how much it hurts and how much it's easier to develop or migrate. And the migration is not that hard in most cases. But if you have a lot of code base, then the migration costs a lot. So it depends on the company that wants it. So good question, good questions and good answers. There's several people who thanked you. You might want to look at the chat now and see all the people who thank you for the good talk. I don't see any more questions. If someone wants to ask another question, unmute yourself and ask directly. You don't have to go through the chat.
I don't want to take too much more of Katrina's time. So if there are no other questions,
then
I'll happily hand it over to you to hand it over to Katrina.
Katrina, please take over the screen, press the present button. And again, James, thank you very much. Usually we have claps, but it creates all sorts of echoes. So I thank you, and virtual claps, everyone. Katrina, please take over the screen, and I'm happy to present Katrina, another member of NumFOCUS, and she's going to talk about NumFOCUS, but she's also going to talk about something related to security that she sees in her role as Chief Data Scientist in Cloudflare. Katrina, it's yours.
All right, thank you. I can't help but jump in real quick and just talk a little bit about that Python 2 versus Python 3 question real quick. Just that, especially since I do a lot of work with the government, I just want to point out that Python 2 is actually like they're huge code bases in the government where they're not necessarily for-profit companies that still need support. So what ends up happening is that they have to create their own internal repositories, and it's actually kind of a big deal. And so I just wanted to mention that it's not just for-profit companies that have the resources to be able to do that migration. And so I just want to throw that out there. So with that, my name is Katrina Riehl. I'm the head of data science over at Cloudflare. And I'm going to talk about two different topics. So first, I'm going to talk a little bit about the cyber attacks that we're seeing over in Cloudflare. And then I'm also going to spend a little bit of time talking about NumFOCUS and kind of what's going on over there. And then even touch a little bit on some of the projects that are being used in the fight against COVID-19. So, two really fun things to talk about. And with that, I'll go ahead and just introduce myself a little bit more. I'm an old Python person. I actually began using Python in 1998. I feel like I've, watched this whole thing grow up. I like to tell the story about my first PyCon was like 30 people in the back of like a Hilton in Washington, D.C. And, the Python community really helped me become a programmer and helped me become, a software developer and eventually, moving on into artificial intelligence, which is my field. So I primarily study artificial intelligence when I was getting my PhD. And since getting my PhD, I've been lucky to only work in artificial intelligence. So I've worked in machine learning in a whole lot of different fields, everything from oil and gas exploration to insider threat detection. Like I said, I do a lot of work with the government, and then also, chatbots and boot camps, anything that you can possibly imagine. I also do want to mention, you know, as I was introduced, I'm the treasurer for NumFOCUS, which is usually, by the way, like one of the most boring jobs that you can have, being the numbers person. But given all of the fun that we're having with the hits to our budget from COVID-19, it's actually turned out to be one of the more interesting positions on the NumFOCUS board, I think. So I'll talk about that a little bit too. Just in case anyone doesn't know who Cloudflare is, we're primarily, you know, a security, performance, and reliability company, and we're an infrastructure company. So the goal being that we want to create a better internet. Today, we have one of the largest networks that powers more than 20 million internet properties. And that means that we actually run metals. So we actually have physical machines all over the world, and we're running our own network. Our primary areas that we work in, like I said, under security, firewall, DDoS protection, bot management, VPN. That's the area that I'm going to be focusing on here. And I did want to mention the lava lamps here. So a lot of people associate Cloudflare with this wall of lava lamps that we have over in the SF office. And we actually use the movement of these lava lamps in order to seed our random number generator, which is used for encryption and all kinds of security issues that we face over at Cloudflare. So it actually serves a purpose, not just pretty to look at. With that, I do want to talk a little bit about the cyber attacks that we're seeing since the death of George Floyd. At Cloudflare, we've seen a dramatic increase in the number of attacks. And so the most important thing I want to stress here, I don't want to get into the politics very much of this whole area, but I do think that it's important to talk about this topic, especially as all of us are, you know, out there in the world and interested in tech, that we talk about what is happening and what's happening behind the scenes, that it's not just protesters in the streets. There's a lot going on that a lot of people are not aware of. And the idea here for Cloudflare is that cyber attacks silence those who need to be heard. And so in order for us to have a real conversation, we need to be able to make sure that all of those voices are heard. And we want to keep all of those online and let them be a part of the conversation. Okay, so what we're seeing, just to kind of set the scene a little bit in case, you know, anyone's confused about the timeline. George Floyd died on May 25th. So the weekend following was March 31st, which is where we started seeing a lot of protests taking place. So it was, you know, I think it took a little while for the video to start going viral and the response to start happening, and then also for the protests to be organized that happened starting the weekend of March 31st, right? And you can see here in this graph that we have here, we're looking at the difference between April and May statistics. From one year to the next. So we're looking at last April and May traffic in order to see what this spike looks like. Oh, did I put March? I'm so sorry. This is supposed to be May 30th, 31st. I'm so sorry about that. But yeah, as you can see, even compared to last year, we see a huge number of new HTTP requests that needed to be blocked. And then we're also seeing that there is a huge jump from 1 month to the next, right? So what does that actually mean, right? We blocked over 135 billion cyber attacks from HTTP requests. That means a month-to-month increase of 17%. And that means that there were an extra 19 billion cyber attack HTTP requests that were blocked. So that means an extra 110,000 blocks per second. And so it's really important to understand the scale of what we're talking about. And we'll get into, I think that they're very abstract when you look at those numbers, but to put it into some kind of context, Google receives about 63,000 search per second on their site. So we're talking about almost twice as many search requests on Google per second were actually blocked. So that doesn't even count the total traffic that we're seeing that we're letting through. These are just the blocked requests. And when we're looking at blocks, we're looking at HTTP requests that are from DDoS, so just distributed denial of service attacks, website break-ins, and then application and API break-ins. So we're taking all of those and lumping them all together. Obviously, you can imagine that the distributed denial of service attacks are the largest attacks that we see, though, because they're just hammering these servers, you know, over and over and over again. But let's look at this a little bit more closely and break down what we're seeing in that jump, right? So that increase of 17%, can we look at it a little bit closer? And so with that, I want to mention that when we look at the different categories of groups that were attacked in this whole thing, the biggest one that we see is in advocacy groups. So you can see, you know, from the 30 to the 31st, this huge spike. And this is a staggering increase of 1,120-fold increase in the number of attacks that we're seeing on advocacy groups. We had almost no attacks at all in April, and then we had attacks peaking at 20,000 requests per second on a single site. So as you can see, advocacy groups were hit the hardest while the protests were going on. And along with advocacy groups, I think it's important to also mention that we are also seeing a huge spike over on the government side. It was maybe not as dramatic, it's not like a 1,000-fold increase, but what we are seeing is on the government website. So this includes fire and police departments. We see it's up 1.8% month to month, and then the attacks on military websites went up 3.8 times from month to month. So we see this huge spike here as well, right? I mean, going from minimal traffic up to this peak here. And so I think it's important to mention that, I mean, these attacks are happening all over the place. There are companies that are being attacked. There are government agencies that are being attacked. There are advocacy groups being attacked. The advocacy groups are definitely getting hit the hardest, but there's a lot of activity in cyber attacks right now. And so this is what I kind of want to bring people's attention to, and make sure that people are aware of what's happening. With that said, I do want to mention that we have a project called Galileo, and this was founded in 2014. This offers free protection for groups that, like nonprofit groups that are a part of artistic groups, humanitarian organizations, and voices of political dissent. These are, online attacks that are usually seen in combination with physical violence and threats. And we see this quite a bit. This is worldwide, by the way. So we have sites that are onboarded from, countries all over the world, and humanitarian organizations all over the world as well. But I do want to point out on this graph here that the blocked cyber attack HTTP requests on anti-racism organizations that are currently protected by Project Galileo is this giant increase right here. And this also, corresponds to what we were seeing before with advocacy groups. It's a 1,125% increase in the number of attacks that are coming to these organizations. And with that, I also want to mention none of these sites went down. We're very proud of that. So everything that has been protected through Galileo, we were able to keep every single site up. And then we were also able to onboard many sites throughout this whole ordeal. And so if you do know of any organizations that need protection that fall under these categories, please reach out. We have the Galileo link here that you can reach out to and apply for help. I'm also pretty easy to find. A lot of people have reached out to me even through Facebook or LinkedIn and things like that in order to help with bring more sites up. And another question I get pretty often is that people always wonder, can we onboard websites while they're currently under attack? So if their server is getting just pounded by some denial of service attack, are we able to still onboard them? And the answer is yes. It won't deter us whatsoever. I am very privileged to work with some of the best in security in the entire country, and they're very, very good at onboarding websites no matter what conditions people are going through. And with that, I just wanted to, open up with those statistics and make sure that people were aware of it. I'll move on to NumFOCUS, but since that is kind of its own topic with Cloudflare, I want to give people the opportunity to ask them questions. And I do want to mention also, those people who know me, I have been around in the Python community for a really long time. I don't usually talk about anything going on at Cloudflare. This is not something that I'm usually very excited to talk about. But at the same time, I do think it's really important for all of us to be aware of what's happening. So with that, I'll just kind of open it up. And does anyone have any questions about Cloudflare and the cyber attacks that we're seeing?
Yeah, I'm kind of interested in how you're able to identify what is an attack versus what is a request, especially for something like a DDoS. You know, that how do you actually identify that it's a DDoS attack as opposed to just a lot of requests?
Sure. So, I mean, that has to do with the flow, where it's originating from, the velocity of how this is going, and then also what they're actually hitting, right? So there are just a lot of different features that we use in order to determine, what is actually an attack. And so, but
is that process automated, or do you have people, do you have like anomalous readings and then you have someone actually like physically look at it?
So I'm going to say both. We do have people that are, we have, sort of our war room that has, all of the sites that are under attack at any given time, and you can see the rate of attack. And I think that probably from every attack that is seen, people learn from it and know what to look for in the future.
Right. Thank you.
Jenny's asking on the chat. Sorry, it moved a little bit. She's asking, are those cyber attacks Cloudflare clients, or are you able to monitor the World Wide Web?
Right. No, that's a really good point, that we're only able to be sure of the numbers that are running through our network. So if you look at this, these are the Project Galileo numbers. So those are the ones that are receiving free protection that fall under the nonprofit, and qualify for Galileo protection. But in order to come up with these other numbers, these are based on things that are on the Cloudflare network. So that is a good point to bring up. That, but what we usually see is that it's a proxy for what is happening elsewhere. Especially talking a little bit about the scale of Cloudflare again, 20 million internet properties, nearly 10% of Fortune 1000 companies using at least one Cloudflare product. We have a rather large base that we're looking at, and so it does help us to monitor what's happening worldwide.
Josh is asking, has the peak of attacks on anti-racism websites subsided, or is it still ongoing?
Also a great question. My understanding is that it is sustained at this point. Please don't quote me on this. I have to actually look at the real numbers from last weekend, but they may even have increased.
James is asking, is it clear whether the attacks are on individuals, private groups, or nation states?
Yeah, that gets into like a little bit of a hairy area, right? Because the majority of attacks that we see, especially with DDoS attacks, are hacked servers. So in particular, especially like the weekend of May 30, 31st, after the death of George Floyd, there was one particular server in particular that was hacked in France that was just like a major source of all of these attacks, and it was just pounding just multiple sites all over the place, right? And so if we're dealing with a hacked server, it's very difficult to tell like where it's coming from. But I think that without me saying anything or revealing anything, you could probably guess where a lot of them are coming from.
People are still joining, so this is good. You probably attract more attention. There's another question. Is there a public document I can refer budding security people to that discusses Cloudflare experience? Do you have any information about this in Cloudflare, or some links that people can follow, basically?
About this particular topic, or just in general about,
I'm just reading the chat.
Oh, okay.
I'm having the same idea as you are, but think about it specifically about the attack issues.
Okay, so I just want to say that we actually do put out a whole lot of information. So anyone who's not familiar with Cloudflare, like we have blogs and white papers and presentations and people speak all over the place. There's a ton of information out there about Cloudflare just in general, and especially in the Bay Area, I think they're much more active in the community. I mean, and also in the open source community as well. Maybe, you know, we're still pretty new to Austin. The Austin office is relatively small until we really kind of exploded in size in the last, I'd say, year or so. So we are starting to have a presence here in Austin, but there's a lot of information out there. All of these public-facing stats that I have here, these are the ones that have been, you know, actually published out on our website. So I imagine that there will be updates out there as well, but you can find all of these on the Cloudflare website.
Katrina, there are more comments there, but I don't see any direct questions. So maybe it's a good idea to continue to the topic that the other topic about NumFOCUS. And I would thank you again by virtual claps, but let's hear about NumFOCUS. It's a very important organization, and this T-shirt is part kind of a NumFOCUS creation. So tell us more about NumFOCUS, please.
Yeah, absolutely. And I just, you know, I'm going to assume that everyone is up out of their chairs, you know, cheering for me. So, you know, calm yourselves. We'll move on to NumFOCUS now. So this is kind of, you know, the state of NumFOCUS. I just want to give people an opportunity. Sometimes I think people forget that we exist, right? That there is this organization called NumFOCUS, and, you know, it supports a lot of open source initiatives. And so I just kind of want to talk a little bit more about NumFOCUS itself, and then some of the challenges that we're facing, and also some of the projects. So the mission obviously is to open practices in research, data, and scientific computing, right? So we provide this, we provide many services for the projects that are part of NumFOCUS that come in the form of community building, promotion, funding, you know, things like that. And so this ties into our vision, right? We envision an inclusive scientific and research community that utilizes actively supported open source software to make impactful discoveries for a better world. Anyone who also knows me pretty well knows that I'm a huge advocate for open source. I have not been an open source developer in a while, which is unfortunate, but, you know, let's face it, open source really runs on the backs of most graduate students. And so back when I was in graduate school, just like everybody else, I cut my teeth on a lot of open source projects. And like I said, it turned me into a much better programmer, a much better software developer in the long run. And so now one of the ways that I try to give back is through community building, grant proposals, helping with funding, organizing, things like that. And so, you know, NumFOCUS means a lot to me. And I do want to also mention that we do have 3 board members here in the meeting today. So Jane is here, as well as James and myself. So we can also answer a lot of questions just between the 3 of us.
And if I may add, Katrina, we also have one of our chairs from one of our events. So Lauren is joining us from both PyData New York and PyData Global.
Oh, fantastic. That's wonderful. Welcome. So, but I do want to also kind of get into a little bit more like what we do. So we have 2 different tiers that we support. So we have sponsored projects. Those are ones that, you know, I guess a little bit higher touch for us, where we can process grants, we can help with grant administration. We do fiscal sponsorship in the form of small development grants, and also participation in Google Summer of Code. Then we also have affiliated projects that are, you know, part of our community that we support with promotion and community. And then also they are also eligible to apply for small development grants as well. But some of the sponsored projects, I'm sure that you have seen a lot of these, NumPy, SciPy, Matplotlib, Pandas, Scikit, Image, ROpenSci, Jupyter, Dask, SymPy, you know, PyMC3, Julia, which we do have Jane, who's part of the Julia team. And then, but it's a huge number of projects, and I apologize that I could not actually put all of the projects here. This is just some of the sponsored projects. So I apologize if anyone, is seeing one that I missed, but I just want to stress that these are projects that people are using. And I think one thing that we really want to see in open source is we want to see continuity, that we're able to maintain these projects. They are a core part of the workflow of a lot of different people, and we want to make sure that they stay around. We want to make sure that they're supported and that they are maintained as a part of our ecosystem. And so I also, with that, want to mention some of our affiliated projects. CPython was one that we were just talking about, QPy, Numba, Pomegranate, Theano, Scikit-learn, GeoPandas, Conda, Yellowbrick is one that I use quite a bit, GenSim, Dash, you name it. And I believe that's NetworkX's logo down at the bottom. But these are also part of our community that we support. So with that, I wanted to move a little bit into PyData and explain what's going on there, because I think a lot of people have heard of PyData and don't understand exactly how it's related to NumFOCUS. But PyData is our flagship educational program. So we just had our first PyData Austin event in December. It was really great to see James there, and I was there. Andy was also another speaker, Andy Terrell, who's also on the board of directors. Peter and Travis and everybody were all out there speaking. And it was really great to move that into the Austin area. But PyData has been going on for quite some time now, all over the world. So PyData events have taken place. I've attended them in Seattle and New York. Just name it. They're everywhere. And so this is an opportunity for the entire international community to come together and share ideas, learn from each other, share each other's work, and get involved in the discussion of like, how are we going to use this? How is this like part of our community? What are we going to do here, right? And how does this relate to their work? And I do want to mention that this is not just a Python community, right? And I think that sometimes people lose sight of that, especially since it is called PyData, but it is Python, Julia, and R. And with that, I always try to remind people that Jupyter actually does stand for Jupyter, Python, and R. And I think some people lose sight of that as well. All three of those languages work in Jupyter notebooks, which also blows people's mind when I do demonstrations of that. It is a larger community than just a Python community, but I think that it really comes out of the Python community, and especially a lot of these projects that have been around for a long time are great supporters of this whole initiative. With that, I want to talk a little bit about COVID-19 response. So I have noticed that in the Python community, there's a pretty big commitment to open source. And I spent quite a bit of time researching different projects in the open source arena, and I was really excited to see some of the work that's going on there, especially repeatable science and making data available, and dashboards and visibility, and everything from drug trials to just to crunching statistics. You name it, Python seems to be involved in all of those. I did find approximately, I believe it was 40,000 open source projects that were related to COVID-19, and approximately 29,000 of those were Python projects, which I thought was also pretty cool. Obviously, the main projects that seemed to be in almost every single project was Jupyter, NumPy, SciPy, Pandas, and Scikit-learn were like the top packages that were used in a lot of these projects. But even if you take into account how many, open, school project type projects there are out there, 29,000 is still really high. And I did want to mention that, while this tool stack of Jupyter, NumPy, SciPy, Pandas, Scikit-learn is pretty ubiquitous for most of the projects that I saw that were sponsored by either government agencies or news organizations, that there are several other, projects that are out there that I think deserve a little bit of a shout out. I apologize once again that I'm only going to talk about a few of the projects that we had that are involved in COVID-19 research, and I apologize to any projects that I leave out. But I mean, is everything from, OBSPI is, one of our projects where they were looking at the difference in seismic activity. With everybody sheltering in place, they're seeing a lot less seismic activity of people moving around or cars out on the road. Like, what is the impact of that change, right? Or we have our project EconArc, which does a lot of economic modeling. What is the effect of stimulus money coming into coming into households, and how is that related to recovery, right? Are we going to need another jolt of stimulus in order to be able to make it through the entire duration of the pandemic, right? And so having these tools open to everyone and for people to be able to reproduce results and talk about science with real data that's shared and open, I think is a really great way for us to, to act in our community. And with that, I do want to mention CondaForge, right? If anyone is not familiar with CondaForge, it is a huge community, really, that provides access to huge computing resources around the world. It has web interface for accessibility, and they have, just a ton of Conda environments in there and Conda packages out there for scientific computing. And I did want to give a little bit of shout out to Galaxy. This is one that's a part of a blog post that we put together for NumFOCUS. And this is a project that relies heavily on CondaForge. So the Galaxy server has 2,000 plus Conda environments, and each of them is powered using CondaForge community. They schedule about 500,000 jobs a month, and all of them are using CondaForge packages. So what they're using this for is to develop new drugs against the virus. This is analyzed over 40,000 compounds considered to be likely to bind to one of the proteases that are in the virus, which were chosen based on recently published X-ray crystallography, and then I identified the top 500 scoring compounds. So it helped to reduce the scope of what they were looking for as they're trying to speed the process of getting new drugs in the treatment of COVID-19. I also wanted to mention rOpenSci, which this one is one that I think that a lot of people have probably heard of. I don't know, but anyway, so this one is important because it's used in several different areas here, right? And so one of the ways that we're seeing this is that they're running simulations of hospital capacity for local governments using rOpenSci. Then also we're looking at, they're using the Cypher package for collaborative, working with sensitive data across a group of about 60 different researchers, right? And that allows them to be able to share information and allows them to be able to work distributedly. And then they're also able to give information to the UK government as well as other countries and NGOs, right? In order to keep people informed about the impact of COVID-19. Then also mentioning some of the visualization that is being worked on in the last one. So you can read that. I know it's a bit of an eye chart, but obviously a lot going on in the rOpenSci community. Then also I would be remiss if I didn't mention Matplotlib, which is another one of those almost ubiquitous packages that I think a lot of people use in their data analysis, and also being able to, just communicate with data. And so this is used, primarily to create scientific visualizations. And so the one that I wanted to call out, because I've seen it referenced about, I can't even tell you how many times. It seems like almost every article I read about this subject seems to always cite this paper. It's the analysis of SARS-CoV-2 viral load by patient age. And so this is the one that you've probably seen a lot of headlines around, where it talks about how the viral loads of different patients of different age categories, that there was no significant difference between the different age categories. So what they're really seeing is that the viral load, regardless of age group, seems to be about the same. Because I think that there was a misconception that, especially since children seem to be less symptomatic or be able to recover quicker, that they may have had a lesser viral load, but it's actually quite the same. And as far as policy is concerned, that may, argue against the idea of reopening schools quickly. we may want to consider keeping kids out of elementary schools and away from each other a little bit longer, since it is not as, it's just as dangerous for children as it is for adults. And especially as spreaders, they are definitely as dangerous. And with that, I'll just kind of open it up again to questions. I kind of flew through that pretty quickly. So any questions that you may have, and like I said, just kind of open it up about anything NumFOCUS related. We do have these board members here, so we can probably handle anything you can throw at us.
I see that there's a comment by James. He said something about Matplotlib, Tom Caswell, the Matplotlib BDFL, found that 25%, more than 25% of worldwide web publications, scientific research, and archive.org uses Matplotlib. Is it a question or is it a fact?
I would believe it.
I think Tom has joined us. He can tell us the real stat.
Yeah.
Okay.
That it's about 15%, but growing. Yeah, based on what they were seeing at SciPy last year. Thanks,
Okay.
Tom. It's nice to have you here.
There's several people who are thanking you multiple times. So many that it's hard to actually figure out what the questions are. So you're doing a good job in NumFOCUS. Specifically about.
I do want to touch on one thing though. You know, I mentioned the PyData community as being something that's very important, but I also didn't really talk about how this is a huge money generator for our organization, right? Us, you know, administering, you know, grants and things like that is not really where the bulk of our money comes to support all these projects. It really comes from the PyData events. And with COVID-19 going on, we're getting hit pretty hard. Our budget is getting hit very, very hard since we cannot have these live events. And we're having some difficulty going into virtual events, right? It's in process, but it's, you know, not complete. We haven't figured out exactly how we're going to do this. So one of the things I did want to mention is that we are definitely hurting. I think we're in really good shape. Like, you know, like I said, being treasurer, I'm pretty close to our budget and understanding exactly where we are. We're in good shape, you know, this year, but if things continue for a very long time, we're going to be in a much worse situation. And so I did want to mention that, you know, a lot of the donation income that we've been getting is also drying up as people are tightening belts during COVID-19, and we don't have the live events. So anyway, you know, maybe just appeal to this audience in general that if you do know people that would be interested in sponsoring or helping to keep this organization going, we'd be more than happy to talk to you and talk about sponsorship opportunities, because I do think that this is a valuable service to the community that we want to keep going.
I totally agree. NumFOCUS has done a lot. I've been following it for years, and I've been in PyData events in multiple continents. It's important that this continues, this effort continues. Do you, except from donations, are you trying to go and do conferences online? This is a question that you might want to ask, because this might be a money revenue as well, doing those conferences online that used to do in person.
Absolutely. I think that that's the intention, is we would like to go virtual. But I don't know if you've noticed, like I've noticed at least, that a lot of the virtual conferences this year are free, right? Or they're at reduced cost because we can't have them in person, right? So even, I'm just going to go ahead and shout this one out. I'll be going to the Spark Plus AI conference in 2 weeks. And this is, you know, I've never been able to actually attend this conference, but now it's free. Like, it's free to attend virtually. So I will be there. And so I think that, I mean, even if we are able to move to a virtual platform, we won't see the same kind of revenue that we do from actual PyData events.
However, you might still have the option of people donating. So everyone who comes in and actually learns something useful, they might be able to donate. So it might be still a good idea.
Yeah,
I can speak to
absolutely.
the specifics a bit if that would be helpful.
Well, I did want to mention real quick that, yeah, we do take personal donations as well. I mean, I donate personally. I know a lot of our board members have, donations in addition to their companies making donations. So yeah, it's not just companies, it's not just sponsorships. People can donate themselves. But with that, I'll let James talk a little bit more about the events themselves. He's, I think, been at like almost every Pi Data since the beginning. So
No, I've only been to like 30 or 40 of them. But,
right, only 30 or 40.
relating to the Pi Data events this year. So last year we had our inaugural Pi Data Austin conference. It was fantastic. As Katrina said, one of the reasons we developed these is in order to feed the fundraising needs of NumFOCUS. One thing that I'll mention is that NumFOCUS has this concept of restricted and unrestricted budgets. And so the projects raise grants, but these go into restricted budgets where the budgets can only be used for specific things that are outlined in the grants. Pi Data is the major source of unrestricted funding, which is funding for things that go across the different projects, such as the NumFOCUS newsletter, the website, credits for web servers for documentation. And so this is a funding resource is actually very, very critical because anything that doesn't fit into an individual project grant ends up falling into this. Now, there's about 2 models roughly for where events seem to be going, even on NumFOCUS events. You may have seen JuliaCon was announced just today or yesterday, and that's going under the free to attend sponsorship model. For some of the Pi Data events, what we're going to do is we're going to try something a little bit different. Rather than just take a normal conference and just dump it on Zoom or Google Meet, we're going to try and see if we can do a conference that when you look at the material that's produced for it, and you look at the hallway track that we build around it and the socializing, gives you an even better experience than an in-person conference. And the reason for this is folks like Lauren, who I don't know if she can join in on voice, but who's joined the call, and our other chairs, have decided to exercise their greatest possible ambition to see how they can make our upcoming virtual event a success. And so for that event, we're aiming for a very similar model to something like Pi Data Austin, just a regular ticketed event. Obviously, since NumFOCUS is a nonprofit, we provide a number of opportunities for people to attend these events for free. Speakers attend for free, volunteers attend for free, there's scholarship programs as well, and we'll be expanding all of these for Pi Data. But for the most part, if you happen to be at a company and your company is doing reasonably well and you want to support the tools, one of the easiest ways for you to support the tools, beyond telling your boss, oh, we should support NumFOCUS and write a check just for NumFOCUS, one of the easiest ways to do that is to say, look, they have this event coming up. This is critical educational information for my own professional development. I'm going to learn about a lot of things that will help me in my day-to-day job. We have budget for training, we have budget for education. Buy me a ticket to Pi Data Global, and that's a really, really easy way for you to support NumFOCUS, a really easy way to support the community, and that's the model we're going to be trying with our virtual events.
Absolutely.
Any other of the NumFOCUS people want to say anything?
Hi, I've heard my name a couple of times. I'm Lauren Olja. I'm here based in Brooklyn. I just wanted to say hi. I hope everyone comes to the NumFOCUS event, Pi Data Global. It's going to be awesome. See you there.
Yay.
When is it?
So the dates haven't been officially announced yet, but I believe it's going to be mid-November.
Do you have how can you apply to give a talk or something?
Great question. So the CFP is, we're kind of bouncing it around the committee, which is we're wiring out. So I'm program chair, right? So I drafted it, and we're gonna make a couple of tweaks, but it's already being passed around informally, and hopefully it'll get posted this week formally. In which case we'll share the link directly with this meetup group. That would be great if you could.
Yes, we'll push it to the emails of all members here.
Amazing. Thank you so
Excellent.
much. Yeah,
Thank
really
you, Jacob.
to seeing submissions from Austin. That'd be awesome.
Austin is a Python town. For everyone who doesn't know it, you're in the right place. James, you made a mistake leaving, or maybe not. Who knows?
All right. Any other questions before we wrap up?
Well, I guess there are no more questions. I don't see anything here. There's some comments. We're going to stop the recording And anyone who wants to continue hanging around, asking things informally, please stick around. I'm stopping the recording now. And